In this video, we're going to try and integrate the inverse sine of x. We are going to try and integrate this. But before we do, you should already know this. You should be able to differentiate this by heart. So force yourself or train yourself to be able to differentiate this by heart. So starting from this, sine equally to both sides. That will then give you this. And then use implicit differentiation. That will then give you this. So dy by dx equals this. And we've done this many times in the past. So if you don't understand this, then track back one of the earlier videos. So dy by dx equals this. But the thing is, you don't want the answer to be in terms of y. So you would then go back to here, to this statement, and then create a scenario in such a way that this statement here is true. Well, you want to create this scenario here, where this here is sine of x. So this length here is x, this length here is 1, so this length here is root whatever here, and then dy by dx equals this thing here. So when you differentiate the inverse sine of x, it will then give you this thing here, and you should be able to do this by heart. Okay, so force yourself to be able to do this by heart. Well, anyway, let's try and integrate this now. We are now going to try and integrate arcsin of x. But visualize arcsin of x. Visualize this as being a number 1 times this thing here. So let u be this thing here. Let v prime be the number 1. So if u equals inverse sine of x, then u prime equals this. If v prime is the number 1 here, if v prime is the number 1, then v would be x. So you integrate it to give you this. So now you blindly follow the instruction here. It's saying get u times v. It's saying get u times v. So that would be x inverse sine of x, and then minus the integral of, it's saying get u prime times v. It's saying get u prime times v. So that would be x over root 1 minus x squared, and then you've got your dx. So this whole thing here equals this thing here. Okay. And by the way, this capital I here, we're just going to call this this whole thing here capital I. So it's easier. So capital I equals this thing here. Now, when you look at this here, hang on, visualize this thing here as this. Visualize this thing here as this. So now when you look at this here, this here is the derivative, or near enough the derivative of the bubble here. So because if you differentiate this, it would be 2x. You see this x here matches up with this. So when you have this to be the derivative of this thing here, then you should easily be able to integrate this. So to integrate this, we are really looking for something. We are looking for this something here in such a way that when we differentiate it, it will then give us this thing here. So hang on, we are trying to integrate this. To integrate this thing here, we are really looking for something in such a way that when you differentiate it, it will then give you this thing here. Well, you should make this. Well, if you look at this here is near enough the derivative of this thing here. So when you're looking for something in such a way that when you differentiate it, it will give you this, make your something here to be this. So we are really looking for something in such a way that when we differentiate it, it will give us this thing here. Well, make your initial guess to be this thing here to the power of 1 notch higher than this. So make this to be your initial guess. So when you differentiate this, so make this to be your initial guess. So if you differentiate this thing goes down here. That will then give you a half, and then the bubble stays intact. The bubble here stays intact, and then this power here gets minus by 1. So that will then give you negative this, and then you've got to times with the derivative of the bubble itself. So that will be negative. Well, if you times the derivative of the bubble itself, it will give you negative 2x. So now tidy this whole thing up. It will then give you this. So the point here is that we are trying to integrate this. So we are looking for something in such a way that when you differentiate it, it will give you this thing here. So make this to be your initial guess. If you differentiate this, it will then give you this whole thing here. You see, this whole thing here is very similar to this. The only difference is that well, if you look at this here is this x here, this here is this here, and then you've got your power of a negative a half, power of a negative a half. The only difference is that you've got a minus here. So you will need to make an adjustment to your initial guess. This being our initial guess, let's make this adjustment. Let's make a negative here. So if you integrate this here, it will give you this. Well, if you integrate this thing here, it will then give you this. So the overall answer here is this. Okay, because it would be a negative here. So you've got a if you integrate this whole thing here, it will give you this. It will give you this. Okay, so forget about this whole thing here. It will give you this, and then you've got a negative and a negative. So if you integrate the whole thing here, it will give you this answer here. Okay, so this here is your final answer.